Scary bunch in front of me. Want to talk about the future of voice, no numbers. But let's start with a little bit of history. Anybody remember these? It's an old crowd, but maybe you don't remember these. These are switchboards. Oh, you do remember them in the back. Excellent. Yeah, I do as well. I worked on them. I joined British Telecom in 1983, and there was still a switchboard in the Threepenny Bit building in Croydon, and I was looking after it. Doll's eyes. The interesting thing is these are around in the sort of late 1880s, and there was a young man who was an undertaker who changed the world. Anybody know who that was? Almond Strowger, my hero, right? So he invented the automatic telephone exchange, and it went into service in 1892. And essentially why he invented it was because one of his other undertaker colleagues, or maybe competitors, had a young lady at the switchboard, and he was losing business. Can't imagine why. Oh, you got a death. I'll put you through to my friend. And he said, I'm not going to deal with that. I'm not going to speak to the people. I'm just going to put all of those switchboard operators out of business by making an automatic telephone exchange. And in 1983, when I joined British Telecom, it was still in service. Strowger, electromechanical staff in 1983. Anybody know what this is? What is it? It isn't, no, but it's the thing in front of that. Yeah, so that you're talking about a stepper switch, and in front of a stepper switch, you had the first ever load balancer in the world. In the UK, you call these uni selectors. In the US, they're called line selectors. But essentially, you get the first selector off of one of these. So when you pick your line up, you get dial tone. Once this has found you a line, so I'm going to pass that around. I'm going to give that to this person, and you can look at how we did software in 1983. It was all programmed by cables and wires and bits and pieces. But the thing that Almond Strowger really invented was the first ever control plane. Before then, it was people. They were the control plane. After Almond Strowger, you would actually tap on buttons, and 3 or 4 years later, he invented the dial. And loop disconnect was a thing. So it was all him and the number system behind it. So if you think about it, 1892, when the exchange went in, we had telephone numbers. We still have telephone numbers now. Over 100 years. That's crazy. Let's get rid of them. So I'm Colin Constable. I'm founder and CTO at Atsign. What is Atsign? You'll find out. Anybody recognize this? I did this search 7 years ago. It's got worse. This is real-time communications. This is completely out of control. There are apps for everything. They're all trying to get hold of your ear. And when I started doing this research, I could not believe how many apps there were. I mean, it's just crazy. We're expected to make all this stuff work. It doesn't work. And it reminded me a little bit about when I was reading about Strowger all those years ago, what he was up against. He was up against this. This is Kansas City in 1890. It sort of looks like all the app madness that we deal with now, but he was dealing with cable madness. And that's what pushed Coy to invent the telephone exchange, and then him to eventually create the automatic telephone exchange. So the question I posed myself and my co-founders was, what would Strowger do? What would he do to solve this problem? He invented the control plane, so what we really need is a control plane. But a control plane that can do a lot more. These are the sort of things we want to develop. So you want to have a personalized telephone exchange. You want to be able to use whatever PBX you want to use. You want to have voice apps. You want to use your rules, not somebody else's rules. What I'm looking forward to, and I didn't hear this mentioned yesterday at the AI talk, but one of the things I'd really like is a speech interface on my phone. So there's some AI listening just to my voice, and I could say, hey, conference in Don. Why is that not a thing? It's because we haven't got a control plane that understands that sort of stuff. Any network, don't care. Any device, don't care. But it's all under my control. This is what we want to do. This is what everybody in this room probably wants to do. It's technically possible, but very, very difficult. Why? Because there's no control plane that can do all this stuff. It's not simple. It's ridiculously complicated. We've seen how complicated it is over the last day or two. So we set out to make this possible by creating something different. How do you really do this? Well, you have to think about networking in a slightly different way. What I call networking 1.0 is where the network address is directly related to the underlying network. So telephone numbers, they're directly related to the underlying network. The telephone numbers are directly connected to a subscriber. An IP address is directly addressed to a device on an IP network. Bank account numbers are directly addressed to the banking system. And mailing addresses are directly addressed to a mailing system. This is a world we've lived in for thousands of years, and we seem to keep developing new networks and always thinking in network 1.0. There's lots of problems with this. Changing a telephone number is ridiculously difficult. Changing a mail address is even more difficult. If you've moved recently, and one of my colleagues he's kept a tally of how many people he had to know about, tell about his new address. He stopped counting after 300. That's how painful it is to change one of these networking 1.0 networks. And what is also bad about this, you can't stop. Once somebody's got your phone number, they can keep calling. And once somebody's got your mailing address, they can keep mailing you. This is crazy. We need to think about networking in a new way. So that's what we set out to do. We call this networking 2.0. And it's really at the core an address for addresses. So you can look up an address and find out what my addresses are. But it has to be end-to-end encrypted. It has to be private. And more importantly, for the same question, I should be able to give a different answer once I know who's asking. So if Don asks me, where am I can say at home. He knows where my home is. He doesn't need to know anymore. If Amazon wants to know where I am, then I can give wherever I am. They can send it to me. But it has to be contextual. Not many things in networking land are contextual at the moment. So we have to be able to give a different answer depending on who's asking, and maybe not even answering once you know who's asking. So end of spam, that's pretty good, and a whole bunch of new services that we can develop as software developers based on that context. So what we really need to do this, and this is what Strouder, I think, would have come up with, and we did eventually, it took us a long time to figure out this stuff, is that end-to-end encrypted control plane. You own the keys, and you can talk to other people with an address, and they can give you contextual answers, and we still use the same data plane as everything else. So that gives you some cool things to do. So we'll go back to Alice and Bob. They're always talking. So if we had one of these new addresses, and it was at Alice and at Bob, and Alice wants to call Bob, we can say, I want to call Bob, and Bob can be known that Alice wants to call you, and then Bob can answer back, we'll use this number. This is the number I'm at the moment. And that could change. That could change instantaneously. It's sort of follow me, but scalable, I guess. What other things can we do? Well, what about asking the app which application you actually want to use? So maybe Bob wants to use WhatsApp. Okay, well let's find out. Let's ask Bob, find out what medium Bob wants to talk to, and act accordingly, and then make the call. This can get pretty complicated, right? So you could ask for the right phone number. You could ask for options, agree which option. This is like a sort of TLS handshake, deciding which algorithm one to use. We could actually imagine this pretty quickly, being able to offer new services and be able to talk across domains. What about rendezvous services? We saw some of this going on yesterday with 911. This could be pretty cool. So what about deciding which codec to use or where a rendezvous point was? So if you could actually talk to the data plane through one of these new addresses, you could actually say, well, give me a rendezvous point somewhere on the network where my socket can meet your socket in the middle, and we can negotiate before we even connect which codec we're going to use. That would be pretty cool. And all this is possible if you have a control plane. So you're probably thinking, okay, Colin, this is a great idea. I love it, but when's it going to happen? Well, I can tell you this, it's already happened. What is the most difficult protocol to communicate over? Which protocol gets very upset if you drop a single bit? Any answers? I'll give you a clue. You probably use it every day. It's SSH. The secure shell. If you drop a single bit, it will drop you because everything doesn't work. So what if I could, and we're going to go to a demo right now. Here's a demo. I'm working on this laptop. It's connected to the same Wi-Fi that you guys are on. And what if I had a control plane to another machine somewhere on the internet and I wanted to make an SSH call to that? And I send a message over to it over this end-to-end encrypted control plane and say, hey, meet me at a rendezvous point, and then let's talk SSH. It doesn't have to be SSH. It could be anything. So I picked SSH because if you get a bit wrong, it's going to throw you out. What would this command look like? Well, it'd look like this. It'd be SSH no ports. Well, if you imagine, we don't need any ports open because the remote machine's going to get this notification and it's going to call out. So we don't have to worry about any network address translation. So SSH from, this is my address, @Constable. And I want to go to this address at @SSH_1. And this is the machine I want to get into. And this is the @sign for the rendezvous point. And let's see whether the demo gods are with us. Probably not, but we'll see. And it's ticking away. And come on. The suspense is killing me. Oh, connection timed out. Well, at least it told me, I guess. Let's try again. I'm assuming I'm still connected. Oh, I'm in. Look at that. I didn't have to trust it. Right, so I have SSH'd into a machine using this control plane. I've sent a message out to that remote machine. I've sent a message to the rendezvous point. The rendezvous point to give me two ports on an IP address, told both ends where to meet. We've met in the middle. We've done a SSH handshake. We've extended port 22. I've connected over port 22, and I've got a shell. This is cool, right? What's even cooler is if I do IPA, you will see that I am on this IP address. So I've jumped over a NAT boundary. I'm on a NAT here, and we jumped over the NAT boundary because we've met at this rendezvous point. You could do RTP this way. It doesn't matter. What's also cool is if we mmap this thing. Everybody know what mmap is? It's a port scanner. If you're not familiar with it, it's what hackers do. First thing you want to do is see what your attack surface is. You'll see there are no ports open on this. That's because the control plane is always outbound, and we made an outbound SSH call. So if you want to have a really super secure Linux box running your favorite IP telephony software, and you want to get remote access to it at your customer's site, get this. It's all open source. You can get it at noports.com. It was a demo that got out of control, and now we sell it. But what we've proven here is that we can have a new addressing scheme that's end-to-end encrypted. We can get keys from one place to the other, and we can get remote access without having any ports open, which is pretty useful in a control plane. So that's that demo. This is how it actually works. So we've got a client, this machine, Linux machine on the remote. We've got a rendezvous service in the morning, in the middle. And essentially what we're doing is extending our SSHD out this way, and our SSH from the remote machine in. We create a tunnel, and that's how it works. The box in the middle has no clue of what the keys are. It never had theirs. It's just providing a socket rendezvous, just a regular TCP socket rendezvous. As I say, it doesn't have to be SSH. It could be anything. It would be pretty cool to be able to join anything to anything. So that's how the underlying technology works, but what else can you do with it? Well, there's a whole bunch of applications, so let's show you some of those applications. So on the left, I have an Android machine, and I'm going to get my Android machine out. This is an app that actually not my company, but a third-party company put together. It's called AdBuzz, and you can get it right now in the stores. And you get yourself a Atsign, one of these networking 2.0 addresses. In this case, it's WiseFrog, and you can look at all the people that have shared information with me. This is not my information. The only information I need to keep up to date is my information. The only information they need to keep up to date is their information. So you can see, like, there's my information. There's a photograph of me at Black Hat last week. And if I want to call somebody or email somebody, I just click this, and it looks up this information. It goes ahead and does it. So that's how it works. But let's get my one up. And there we go. So this is my phone here. And we run the @Buzz app. And you can see that I'm logged in as @AI6BH. And you can see there's some information I've shared. Now, what if I had lots of contacts and I wanted to change some of this stuff? Well, I've got different profiles. This profile is called personal. And let's say I just wanted to change my number to 99. You ready? Let's see what happens. So at the moment, did you see that? It happened in the blink of an eye. This is updated to 99 here. Let me change it back again to ready, steady, go. There you go. These are two independent Atsigns. There's no database in the background. This is all distributed. There is no blockchain. It's essentially end-to-end encrypted communication from this phone to that phone. And there is a couple of microcontrollers for every @sign or address has its own microcontroller. You can run it, I can run it, doesn't really matter. But the microcontroller in the middle never has your keys. So the only two devices in the universe that can see this data is this phone and that emulator. And what's sort of cool here is that I'm changing things on my phone, and it's automatically changing data on the other phone. So keeping up to date. But there's no reason this couldn't be inside the network. There's no reason for me to have a phone number anymore. I could just have an @sign, and then you can put your customers in control as to where this information comes from. There's a whole bunch of other applications. That's @Buzz. There's another one called Atmosphere Pro. It's being used in Ukraine at the moment to send information, mainly videos and pictures, without having to give away a telephone number. Why is that important? Well, if you're in the Ukraine right now, you probably don't want anybody else knowing your phone number. And all the apps that are out there at the moment seem to key against phone number. With a networking 2.0 address, you can go get one at atsign.com. You can get one for free, knock yourself out. But it's not tied to a phone number. Nobody knows on the network who you are. It's end-to-end encrypted. You developed your own keys. We never get to see them. We can't see your data. The only people that can see your data are the people you want to send data to. So, what if every device out there had an @sign? If that happened, then I could make a call to anything. We disconnected the hard connect network level 1 phone number to a device. You don't have to log in. It's always going to be at Mike's desk phone. But I can just say, where am I? Well, I'm at Mike's desk phone. Maybe it connects via Bluetooth and it says, contact me on the nearest phone that's available. It just happens to be I'm in Mike's office, or I'm in the goldfish room, or I'm Bob's Starfish. When somebody calls me, that device should ring. I should be able to do the go into a conference room, or I'm on my cell phone. I should just be able to do the flick like this, and it should go straight to whatever displays in the room. That's only possible if everything's addressed in a new way. That's only possible if everything has got this network 2.0 type address scheme. So how do you create all this stuff? Well, frankly, I've had enough work to do inventing and producing everything to make all this possible. So what we've done, we've built the control plane. It's all done. What we have created is a bunch of SDKs for you guys to make all this stuff exciting and bring it into your world. There's a whole bunch of possibilities. Love to speak to you about it. I'd love even more to show you where the code is and get yourself going. It's not complicated. We've made it crazy simple. Essentially, if you can put to a database, the only additional thing you need to do is say which Atsign you want to share that information to. That's it. Everything else is done for you in the SDK, all the encryption, all that complicated stuff. But it's going to take a community to bring all these wonderful ideas that we've had for decades now into the reality. And the only way I can do that is by building a community with you guys to take our SDK and bring it into the world. Which means, ultimately, everything's going to be networked. And when I say network everything, in the 1.0 world, each one of those networks is in its own island. And you can't, at the moment, do things because everything's in network 1.0 world. We're limiting AI because we've got this ball and chain of networking 1.0. It's not end-to-end encrypted. It's hideously complex. You've got to speak to the network guy to open up ports. Nobody's had fun doing that. But if everything's outbound and all the rule sets are deny incoming and yet everything worked, just like you saw the SSH demo, wow, we can accelerate the way Strowger did in the 1890s. So that's my dream, and I'm pretty sure it's all coming true. It already is into other domains. This is the first time I've let anybody in the real-time communications world know what we're doing. ClueCon was obviously the right place to do that. Hopefully you like what you see and you want to get involved. Thank you for your time. My @sign really is @Colin, and if you go to waving @Colin, you can see my personal profile, get hold of me. But if you're a developer like me, you don't really care about that stuff. You really care about this. I have a paper on networking 2.0. That's in the tiny URL down the bottom. Join our Discord channel, get an @sign. The full SDK is on GitHub. And if you want a really sort of beginner's guide, then go to my personal GitHub repo and go to @getting started. And there's some really simple, sort of less than 100 lines of code, you can get something working. Rescue me, David.
Thank you very much, Colin. Thank you indeed. Let's give him a big round of applause. Now, Colin has thoughtfully left a few minutes for questions. And so if you have got a question for Colin, we've got a gentleman running the mic at the back there. So who's got our first question for Colin in this brave new world? There's one at the back. Is it Yakshan?
Be kind.
Okay. Oh, don't worry, I'm kind. I just wanted to understand when you said the meeting, the rendezvous point.
Yes.
What hosts the rendezvous point? Or what is that on the hardware side or network side?
So it can be anything. It's open source software. It will run on pretty much anything. Currently, the ones we've got, the one that I was using there is just running on a Linux box out in the cloud. It has an @sign. It has its own set of keys, and the data that goes through is just regular data. So there's no vulnerabilities or anything there. You're just using it as a hopping point. But if you want to set up your own rendezvous points, and actually that's who we're working with a bunch of telcos and manufacturers at the moment. You want to set up your own rendezvous point somewhere? It literally is 100 lines of code to get it up and working. It's multi-threaded and can handle up to about 2 gigabits of traffic. If you run it on local host on your machine. So really, it's just really the network bandwidth that holds it back. Fortunately, there are some pretty cool providers out there that don't count your network bandwidth anymore. So big shout out to the guys at Blue VPS. They've helped us out a lot. If you haven't heard of them, then go look them out. They've been an excellent partner.
Okay, thank you for that one. We've got a question here as well. Mike, hold on, sir. The microphone is coming your way for the purposes of the live stream. Here we go.
Do the rendezvous points federate a la Mastodon?
No, they're completely independent, independent entities with independent network 2.0 addresses. Could you write software for them to federate? Sure. Have we done that? Sure. Do you have to? No. This is completely open source, distributed, do whatever you want. As long as you've got like an Atsign address, it can address you to wherever else. The other thing that's pretty cool is you can do, there's sort of lots of causal effects of having this networking 2.0. You can read in the paper that is down the bottom there. And one of the causal effects is you could get a third party, another Atsign, attest that this is really the John Doe or really the phone. And if you both agree with, if you both can agree that the tester is somebody trustworthy, then you can have federated trust. And we actually have a blockchain company now building a blockchain on top of our protocol. So you always know that a protocol has come of age when another protocol is using your protocol to build their protocol. And essentially, what their blockchain is based on is proof of trust, which means they don't have to do this sort of crazy world of confirmations. You can have an instantaneous blockchain, and you can run it on a mobile phone, which is very cool. I would never thought I'd have a blockchain running on top of this protocol, but it works a treat.
Excellent. Thank you, Colin. Did that answer your question, sir? Okay, Moshe.
Okay, well, thank you very much for answering part of my next question, which was going to be precisely how do you prove when you type in at Constable, yes,
yeah.
at a point I've reached Constable and not his Russian doppelganger.
You got it, yeah, no, that's super important. So, number one, every Atsign at its creation, you create your own cryptographic keys as a set of keys. One of those keys is your public key.
Okay, but the point is, sorry, let me rephrase it this way. I'm calling you for the first time. I'm typing in your name. I don't have your public key.
Correct.
I have nothing other than a random
string
site.
Yeah,
well, no, it's worse than that. I have at Constable, I'm assuming, and there are about, let's say 30 or 40 million different places where I could try to look for at Constable, I assume. So how do I know I've reached the right at Constable and it's not your Russian doppelganger? That's really my question.
Okay. So the address is just like every other address. The address is only useful if there's only one of them. So there's only one at Colin, and there is only one directory where you can look up at Colin. But it's a classic sort of classic encryption problem is like, how do I know that that's already your public key? Well, the first thing is, probably the best way to check it is when you meet me, you say, is this you and you, and we send a message and you cache that public key. And if I ever change that public key, then I sign it with the previous public key and life's good. So we haven't solved that problem. The other way of solving that problem, there are companies out there that prove that I am the Colin Constable who lives in California that's had 40 years in telco. And we can both say that we trust that entity. One of them is IDEMIA, that you'll see them when you go through the TSA. And you can sign up with IDEMIA, and they will attest. They're an attester that say, at Colin really is this person. And they provide services that allow you to do a photograph scan, are you over 21, all that good stuff. I'm not in that business, but I am in the business of allowing you to contact an attester that you trust, and a tester that I trust, and then you can have that guarantee that I'm not some Russian mobster. But you can't do that at protocol level. You're absolutely right. It's just impossible to do that. I've spoken to a whole bunch of people, and that was actually the first thing that when I met Window Schneider, she's a famous lady in the world of cryptography, and that was her first question. So you're in line with Windows. So, and I told her what I told you. I haven't solved that problem. It's an impossible problem to solve. But what you can do is solve it through a testament.
Thank you, Moshe. And I think that's probably enough time for questions there. If you'd like to talk to Colin, or Conrad Constable, as he's sometimes known, he will be around here for the duration.